Welcome to the class. Dear students, today we are going to study what is acid value. Before studying acid value, we should know what are the components of a fat. So let us start. A fat is made up of two components. One is glycerol. Glycerol is nothing but a trihydroxy alcohol. See, look at this, trihydroxy alcohol. And the second component is fatty acid. Now fatty acids are long chain carboxylic acid, not short carboxylic acid, long chain, 12, 14, 16 carbon atoms. Long chain carboxylic acids are called as fatty acids. This is glycerol. What would happen if an alcohol reacts with acid? Yes, it would yield us an ester. So I draw that ester here. It's actually a triester of fatty acids linked to glycerol. It's actually a triester of fatty acids linked to glycerol. So that is what is a fat molecule. We also call it as a triglyceride. So a fat molecule looks like this, or a triglyceride look like this. Both fat molecule and triglyceride are the same thing. It is the triester of long chain fatty acids linked to glycerin or glycerol. Now what would happen? Now suppose, imagine a situation where you are going outside on a long vacation and this is the oil that is in your house, right? It may be a coconut oil, it may be a mustard oil or a groundnut oil. This is the molecule of oil, general structure of the molecule of the oil. And you are going for a long vacation, you opened the can and you went away. After the vacation, when you came back, you will find that the oil has now, it is spoiled. So what has happened in that oil? In that oil, it has reacted with the moisture in the air and it has led to its degradation. So please note that when an ester molecule reacts with water, when it is hydrolyzed, what would happen? Yes, you are correct. It would give you this and this back, right? It would give you glycerol, the alcohol part, and the free fatty acids back, right? So you would get this thing back, the free fatty acids back. Now the free fatty acid won't exist in this form in the oil sample or in your groundnut oil. I will tell you in what form it exists. Here we are writing very RCOH, looks very decent here, but in your oil sample it would actually look like this. I am reminding you that this is a free fatty acid, it is a weak acid. So weak acids always go for equilibrium. So it would exist like this. Now this would make your oil very acidic. So the oil will taste sour. Okay, it will have a sour taste and there will be a foul smell of oil. This situation of oil is unfit to use, makes it unfit to use. And we call such an oil a rancid oil. What do we call? A rancid oil. We say that the oil is rancid. Now I have taken rancid oil and I have had a lot of issues with rancid oil, like acidity and other kind of GIT problems, regurgitation and all. I have read a literature survey also indicates that rancid oil long-term usage causes cardiovascular events and other major health issues. So rancid oil is actually it is very harmful to use and it is unfit to use. So we have to determine what is the amount of free fatty acids in our oil sample. We have to determine what is the amount of free fatty acids in the oil sample. Only then we will be able to determine whether the oil is rancid or not, and if so, to what extent. So this is very important for us to determine the amount of free fatty acids. Now this can be determined by acid value. That is what acid value is all about. Acid value, you can say, in four things about acid value. Okay, all things are same. Acid value is a determination of the free fatty acids in the oil sample. What is the significance of acid value? It measures the free fatty acids in the oil sample or in the fat sample. Or you can say that acid value gives us the extent of hydrolysis. Okay, extent of hydrolysis to yield free fatty acids. Or you can say acid value is the extent of rancidification of oil. It gives you an idea of how rancid the oil is. Or you can also say that acid value gives you the idea of freshness of oil, whether the oil is fresh or not. So all these things you can find in textbook. It is one and the same thing, right? Acid value, the first one is the correct and the most apt significance, that is acid value gives you the amount of free fatty acids in the oil or fat sample. It gives you the idea on the rancidity of the oil, or how much rancid the oil has become. It gives you an idea of the freshness of oil, or it gives you an idea of the how much extent of hydrolysis hydrolysis has occurred in the oil sample or the fat sample. All these words you can use for indicating the significance of acid value. Now we will come to see how acid value can be determined. How can acid value be determined? That is what we want to see. How to determine it in lab? The amount of free fatty acids in our oil sample, how much it is, how will we determine? Before that, let me tell you what acid value is. Acid value is milligram of KOH that is required to neutralize free fatty acid in 1 gram of oil or fat sample. In 1 gram of oil or fat sample. So that is acid value. What is it? Milligram of KOH. That is the most important thing. So if it's in gram, if the result is in gram, you have to convert it into milligram. Correct? So that is, if it is in ml, you have to convert it into milligram. Correct? So milligram of KOH, which is required to neutralize free fatty acids in 1 gram of oil or fat sample. So what would be the unit final reading, whatever you are getting? The unit will be milligram per gram. That is milligram of KOH required to neutralize fatty acids in 1 gram of oil or fat sample. So this is the unit that you will add to your final answer. Okay. Now how will we determine it? Let us see. For this purpose, you take conical flask. My drawing is a little weak. Okay. You take a conical flask. Now you add your oil sample or fat sample in the conical flask. Now before adding the oil sample or fat sample, do not forget to weigh it, because we have to give answer in per gram of oil or fat sample. Free acids in per gram. So per gram we have to calculate. So don't forget to weigh it. Okay, we will use the total weight in the equation. So take that weight. Now assume that the oil is in the conical flask. You need a solvent to solvate the oil. So what kind of solvent you should use? That solvent which does not interfere with free fatty acids, which has no influence on free fatty acids or on CO groups of the triglyceride. Our solvent should not influence these, right? It should neither have any effect on free fatty acid, nor it should have effect on the ester groups of the triglyceride. So we need something that does not ionize, right? So we need a non-polar solvent. So for this purpose, I use N-hexane as solvent. N-hexane as solvent. Now I put N-hexane also, and I made my oil sample soluble, right? Now I also add phenolphthalein. Phenolphthalein, 1 to 2 drops is enough for phenolphthalein. Now in the second step, I have to determine free fatty acids in my oil sample. So what I will do, this is acid base titration. We are having acid here. We have to titrate it against a base. So now I will use the base 1 molar KOH solution. That is what I will use, 1 molar KOH solution. Now I have started the titration. Okay, drop by drop my KOH is falling in the conical flask, right? So what would happen, drop, initially it is acidic, and slowly my acids, free fatty acids here, it is reacting with KOH. So my free fatty acids are reacting with KOH that is falling from the burette, and what I get is potassium salt and water. So now this is acidic pH, right? The solution here is acidic pH. Now we are going for neutral. This is neutral, right? So slowly as a drop of KOH is falling from the burette, slowly the pH is getting neutral. As free fatty acids are getting consumed, the solution inside is proceeding towards neutralization, correct? There will be a point when whole of the free acid has reacted. There will be a point in this titration when whole of the free fatty acid has reacted with KOH. At that point the solution will be completely neutral. It will be completely neutral. The next excessive drop of KOH that will fall, what it will do? It will make the solution alkaline. What it will make the solution? It will make it alkaline. Now when the solution is alkaline, there is one more thing in the conical flask. Do you remember? Yes, phenolphthalein. Phenolphthalein was stable in acidic condition, but when the solution became alkaline, it ionized, and that ionized phenolphthalein is pink in color. So because ionized phenolphthalein becomes pink in color in basic media, the whole solution here becomes a pink in color because the whole solution is basic. So now because phenolphthalein has ionized and it's pink in color, the whole solution becomes pink in color. So when you get that pale pink color, what do you infer? What do you conclude? What is the conclusion? You infer that whole of the free fatty acid has reacted or has been consumed by the alkali, and inside my conical flask the solution is neutral and there is 1 drop excess of KOH. So that is what you infer. That is the time when you stop the titration. Stop the titration because everything has been consumed. All free fatty acid has been consumed by KOH. So you can stop the titration and note down the titer value. I would say that is sample value. Okay, I will name as sample value because that is a value when sample was present, sample of oil or fat was present. Note down that sample value. Similarly, you go for determination of blank. Conduct a blank titration. So in blank you would not use any oil. You will use N-hexane, you will use phenolphthalein, you will go for titration against KOH, but you will not use any sample, correct? So if you will get a very small value for blank. Okay, that is because N-hexane may have minute traces of free fatty acids. There is probability which is very less, but still there is a probability that N-hexane has minute traces of free fatty acids. So for that you will get a small value of blank. Okay, some KOH might have been consumed, so you will get a very small value of blank. So that has to be subtracted from sample value, right? That way we will get the true titer value. Okay, the real titer value will be sample value minus blank value. This is owing to N-hexane that has been used as a solvent, and this is owing to only N-hexane plus your sample, that is oil. So when you subtract it, whatever is owing to n-hexane, that will be subtracted, and you will get whatever is owing to your sample. Correct? So it decreases the titration error. This system decreases the titration error. That is why we have conducted the blank here. Okay. Now to put it in the equation, you need to know one more thing. See, acid value is milligram of KOH, right? And we have used what? We have used liquid KOH, ml of KOH, right? So today we have used 0.1 molar KOH. So you need to correlate everything, okay? So the equivalency is 1 ml of 0.1 molar KOH that we have used today in the lab, that is equal to 5.61 milligram of KOH. That is equivalency. Okay, if from my burette 1 ml has fallen into the conical flask, that means that 1 ml is equal to 5.61 mg of KOH. So that is the concentration equivalency of ml with mg. I hope you understand this. If 1 ml from my burette has fallen into that conical flask, that means what has fallen? 5.61 mg of KOH is fallen. Okay, so rest is water. So 5.61 mg of KOH is fallen. So you please note it down. This is the very important thing. Now you put it in the equation. So the equation is acid value is equal to 5.61. Okay, that is for 1 ml into whatever ml has fallen divided by weight. So that is the equation. 5.61 means for 1 ml. This is the mg. Okay, and whatever has fallen from my burette today, maybe it is 5 or maybe it is 3, whatever, maybe it is 10, whatever has fallen, that you multiply it, you will get what? The total mg, right? The total mg of KOH you will get by weight. Okay, the weight of the oil. So you will get, when you do, you will get mg per gram. You will get answer in mg per gram. I hope you understand this equation. This equation is very important to understand. This is for 1 ml, the mg. 1 ml of 1 molar KOH has 5.61 mg. This is whatever was fallen from my burette. Okay, my volume, my titer volume, divided by weight. Weight means weight of the oil or fat. So you will get per gram. So this is total mg, numerator is total mg, per weight means mg per gram, you will get answer. Dear students, this is perfectly okay when 1 molar KOH is used. But in lab, we know, in our labs, 1 molar KOH, if we are intending to prepare 1 molar KOH, there may be a case when 1 molar KOH is not prepared. Sometimes it may be less than 1 molar, or sometimes it may be more. The strength may be more. So how to adjust those differences in this equation? Let us see. In that case, what we will do is acid value is equal to, we will use that 5.61 equivalency into actual molarity into titer value. Let me write titer value here. Titer value into actual molarity into equivalency. What is the equivalency? 5.61 divided by total weight of the sample into given molarity. Given molarity is 0.1. I will explain you how this came. Let me explain you how this came. This is, I think you know, okay, you can well understand. Let me explain to you how this came. See what I told to you, 1 ml of 0.1 molar KOH has equivalency to 5.61 milligram of KOH. I told you like this, correct? So if you want to calculate for suppose 0.09 molar KOH, if you want to calculate, if by standardization whatever you intended to prepare 0.1 molar KOH in the lab, but because of human errors what you have got after standardization is 0.09 molar, then how much it will be equivalent to, how much milligram of KOH will this be equivalent to? So this can be find out by 5.61 divided by 0.1 into 0.09. Right? Shall I write it here? Actual molarity 0.09 into 5.61 divided by 0.1. I hope you got it. 1 ml of 0.1 molar is equivalent to this much. But today, due to human error, whatever I have prepared, this is the strength 0.09 molar. Okay, I found it after standardization against oxalic acid. So how will I calculate for this one, for this much strength, how much of mg? This is the mg of KOH for this much strength. So this is what I have put here. Fine. The same thing is there. What I told, the same thing, but a little adjustment for the variation in the standardization value. Correct? So that is the thing. Now if suppose you have made normality, if the strength of KOH is normal, you have made in normality, in that case your equation will be the same, that is titer value into actual normality into what is the equivalency, 5.61, this is 5.61 divided by weight into given normality. So we know equivalency for molarity, 1 molar. There is equivalency for normality. That equivalency is 1 ml of 0.02 normal KOH is equal to 0.00561 gram of KOH. Correct? Now this is in gram. We need in milligram. Correct? So you convert it in milligram. 5.61 into 100 you do into 1000, you will get it in milligram of KOH. So that you convert it into milligram here, so that you get answer in milligram. So given normality is how much? 0.02. Correct? Suppose your normality is 0.01, then what you will do? Right? If your normality is 0.019, then what you will do? What you can do is, see, this is for 1 ml. 1 normal KOH will be how much? For 1 normal KOH, just divide it 5.61 into 0.02. If today you got 0.019 normal KOH, if today's strength, okay, you intended to prepare 0.02 normal KOH, but after standardization, because of human error, and after standardization, if your value is 0.019 normal, then for that kind of KOH, that strength of KOH, what would be the mg of KOH that would fall in the conical flask? For that, you will have to divide it by 0.02 and multiply it by your 0.01. So that is what you will write here. Your actual normality 0.019 and your given normality 0.02. Right? I hope you understood it. If your strength is in normal, not molar, then the equivalency is like this. Right? So this equivalency is in gram, converted into milligram, because acid value is to be given in milligram. So you multiply it by 1000, you get it into milligram. Write it here. Okay. Now this is for this strength of KOH. If your strength is not this, then what would happen? That is a question. So if my strength, today my strength is this much, right? Because I am human, I make errors. After standardization, I found that the strength is this much only. Then how much mg is there, that you can find by dividing it by 0.02, like look at this, dividing it by 0.02 and then multiplying it with whatever normality you have got. So in this way you can determine acid value. The final unit of acid value will be something, the units will be milligram of KOH that has neutralized free fatty acids in 1 gram of oil or fat. Dear students, I hope you have understood the concept and the mathematical calculation behind acid value. If you like the class and if you have understood it, please do not forget to subscribe this channel. Thank you very much.